All right. So my name is Eric Allam, and I want to talk to you today about building better transitions. So naturally, I'm going to start in 1986. In 1986, John Lasseter and his colleagues at Pixar screened the short animated film Luxo Jr. to the SIGGRAPH conference, and it received a standing ovation. And it wasn't because of the advanced graphics; it was because of the animation that was used was like nothing before seen in the 3D world. So John Lasseter, before this, he was an animator at Disney, and so he used the animation principles he learned at Disney combined with the 3D graphics to really bring these characters to life, and it kind of added emotion and meaning and everything. And these principles, stuff like anticipation and timing and staging, they were developed by the Disney animators back starting in the 30s, I think, 1930s, and perfected over the years. And so what these animation principles allowed Pixar to do, and which I think kind of makes sense for thinking about when we're thinking about animations in our own app, is that it creates this, it mimics physical reality in an interesting way. And for our own apps, that's important because on iOS especially, we want to kind of create this physical context, right, for our apps and for the whole system, really. I mean, the home screen, if it didn't have any kind of physical context, didn't have animations, it would just pop your apps in when you tapped on them, and that's no good, of course. And so instead, it has this zooming animation, right? And so this physical reality, this mimic physical reality, is really important, especially in transitions, because this is where this is really high stakes. We have entire screens moving in and out of this. In and out of our apps, we're moving things around. Our users can get lost. So, and this is our opportunity to create that physical context to give our apps a physical space that it kind of makes sense. Our users kind of start creating a mental model, and they get in flow easier, and they use our apps, and the apps are better. So, I kind of want to look at some of these principles of animation, how they apply to the transition system, right? And so there's a lot of them. There's, I think, 12, right? And here they are. And obviously, I don't think I have time to go over all of them, so I want to focus on a couple. Timing, arcs and appeal, and staging. Arcs and appeal is two, but we're going to do them together. So, timing. It's not just picking a timing curve and then you're done. Actually, timing is the speed of an action. It gives meaning to the motion. If you can imagine, I mean, especially in cartoons, you can imagine the speed that something is done could mean completely different things. But for our apps, really, it comes down to this, right? Or especially transition, right? We're moving something off screen, moving something on screen. We don't want to do it too slow, because it would be boring for our users, and they'll close our app and use something else. And we also don't want it to be too fast. Too fast leads to this problem called strobing in animation. For example, this animation is too fast, so it doesn't look right? We have to increase the duration to get that smoothness, and it's that balance between having something that's too fast and it strobes, and something that's smooth and works really well, but it's not too slow. But it's not just about duration. Speed is the duration over a distance. So back to that example, if you decrease the distance of the animation, right, it's another lever you have to control the smoothness of the animation. So if you're thinking about something like a modal transition, and you want to alert view kind of sized custom transition, right? You're going from the top to the center. And on iPhone 5, that would be something like 284 points. And so you'd want to pick a duration that made sense for that distance, right? You can think, well, how can I cut it down a little bit? You could start from the side. If you start from the side, maybe you only have 160 points to cover, and you could decrease that duration. And if you look at the default transition times for like the navigation transition, since it's coming from the side, it has less distance to cover. It's only 0.35 seconds, and a modal default duration is 0.5. That's because it has more space to cover. So like I was saying before, the default transition, I'm mainly going to be focusing on the modal transition for this talk. So the default one looks like this. You've seen it a million times. It's 0.5 seconds. Has a custom spring animation, which you can't actually create yourself, but you can get pretty close using the new spring animation APIs in iOS 7 with these parameters. And it's only full screen, right? Like we couldn't create that alert view like I showed in that last example. So let's say we wanted to build something like this. We want our presented view to be smaller, alert view size, and we want it to come in from the top instead of the default, which is the bottom. And so we have to build a custom modal transition. New in iOS 7. How many people here have actually implemented like a custom transition using iOS 7's? Okay, I figured it was going to be a bunch of people, so I'm going to kind of skip over the boilerplate of setting up, your custom transition. I want to dive into the animated transitioning object, which is basically what you use. You create a class that conforms to this protocol, and you use these two methods to control the transition. So transition duration tells the transition system how long it should take, and then in animate transition, where we're going to be spending all of our time today, this is basically where you perform the actual transition. Both of these methods take a parameter that's known as like the context, and it conforms to this protocol. There's a bunch of protocols in this system. And it gives you access to stuff like the from and the to view controllers, and as well as this container view. And you can get access to it like this. And so when you first, you build your custom transition, you fire off, you present a view controller, and before, like right when the animate transition starts, the state of the view hierarchy looks kind of like this. That container view, like I was saying before, is this UI transition view, and it's between the window and the presenting view. And so this gives you like a common place to do your transition, right? A common super view. And so in this example, we're calling it the root view controller. That's already in the hierarchy. You don't have to do anything, right? But the view you're presenting isn't in the hierarchy yet, right? So it's your job as the transition creator to add it to the hierarchy. And so that's what you do. That's one of the first things you do. Add the to view to the container view. Set its initial state, animate it to the final state, and then complete it using that transition context parameter I was talking about. Right, so if we wanted to build that example top-down transition with alert view style, we basically in animate transition we set the balance to something smaller. We set the center to the top of the screen. We add the to view to the container, and then we animate it. Right, and we animate it to the center, and then when the animation completes, we complete the transition. So that's the pattern. So we still haven't picked a duration, and in general, I think if you're designing one of these transitions, you want to have it something that's more than 200 milliseconds. 200 milliseconds is about the average person's reaction time. Like that, we're actually pretty slow. 200 seconds is how quick we can react to a visual stimulus. And actually, I think Olympic athletes, especially the sprinters, can react to, I think, about 100 milliseconds. That's like the best that we can do. And that's auditory, which is actually faster. But 500 milliseconds, once you start getting up there, you're making the user wait a little bit too long, right? So this is kind of our playing field of duration times. And so that would look something like this, right? I think this is 400 milliseconds. So it's pretty simple, but I actually think it probably could go a little faster. But we haven't really talked about timing. I'm sorry. we have talked about timing. We haven't talked about the curve. And that's because there's actually a whole principle. The Disney animators loved slow in and slow out so much, or as we know it, that it's its own principle, because they use it everywhere. And this has to do with the acceleration of the animation through the duration. And so this is really nice because UIKit, by default, uses ease in and ease out. So we don't have to do anything to support that. You probably just should use it. Never use ease in or linear, especially not linear. That's terrible. Hey, all right. But there is this other principle that they have, kind of conflicts with that one. It's called follow-through. And this principle is basically like if you're running really fast and you try to stop, you're not going to stop right away, right? You're going to keep going a little bit and then come back. And so the Spring Animation APIs are really good for doing something like this. And Spring Animation, I think, creates a actual better movement. So if you're using just the default, not Spring Animation, use ease in and ease out. If you want to do follow-through, use Spring Animation. That brings us to the next principle, arcs. Stuff in the real world doesn't move like our views do in a straight line all the time. They move in arcs, right? And this, I think we can accomplish this principle in our transitions by combining it with this other principle known as appeal, which is something flashy, not flashy, but think of cover flow, right? No one actually used cover flow, but it was like a good demo. And it's like the word magnetism, people want to use your app because of this, right? And so we can combine these two in a certain way, and I think that way is by doing a 3D perspective. So when you add that 3D perspective, that's slowed down, obviously, it rotates, right? You're going to rotate it around a 3D perspective, so that takes care of the arc. And then the subtle, that's probably important, make it very subtle. 3D animation helps with that appeal factor. So we have to enter the third dimension in our apps. But that's, our apps usually aren't in the third dimension, right? How do we get to that? And we do that by using something called CA Transform 3D, which is part of core animation. So we have to kind of go down into the core animation layer. And CA Transform 3D is basically CGify transform plus the z-axis, right? It's got an extra entry. And what it does is it allows us to set this magical entry in the matrix, M34, and it basically will add that 3D perspective. And that's a really small number we're setting it to, but that's all it takes. And if you think about it, the pattern is usually set it like this because if you do this, the right side, the divisor, is actually like the distance the camera is from the views. And so 500 is just you can just pick it out of a hat and you can mess around with it and see what works best, right? So how do we apply that to a transition? And I think the best way to do it is to create that perspective transform and then set it as the sublayer transform on the container layer. Now, a sublayer transform so it takes that transform and only applies it to the sublayers. That makes sense. And so it doesn't, and if we do it like this, it doesn't apply it to the container, right? So our container, which is that UI transition view, doesn't get that 3D perspective, but all its subviews do. And the other good thing about this is that when you add a 3D perspective, you have this notion of a vanishing point, right? And if you set each of the subviews perspective individually, each view will have its own vanishing point, its own coordinate system. But if you do it like this, all the views will have the same vanishing point, which is, that's what you want. And so once you set that perspective, you can start doing stuff like this, like start the two views slightly rotated in the x-axis. And a note here also that we're changing the anchor point because we want it to rotate around the top of the view and not the center. So the anchor point default is in the center. And then we also have to adjust the position because if you adjust the anchor point, it adjusts the position, so we have to do that. And then when we animate, we just set it back to the identity transform, which will do that rotation. And make a note here that when the animation completes, it's really important that we reset most of this stuff. And that's because we want to have, we want it to be in a consistent state. And if you don't change the anchor points back and the transforms, weird things can happen after the transition is finished. So make sure you do that before you complete it. But that's it, But you just have to be careful of not going too far and doing something like silly, kind of like this, right? It's a bit too much. It's like too much appeal. It's a little garish. So it's best used subtly. And Airbnb, actually, I think they released a new app, so I don't know if it still does this, but they actually do both, right? So their sidebar is a bit much, I think, but then they have this really nice modal kind of slide in, and the from view kind of like moves out on the x-axis a little bit, which is really nice. So some guidelines for when you're doing these 3D transitions. Like I said, reset the anchor points, the transform, the positions on completion. Add that perspective to the container view's sublayer transform, and don't try to get spring animations to work because they don't look great. So the last one is staging, and that is basically that the principle of presenting your main idea clearly. And when I thought about this principle and how it applies, I think it applies in a very specific way, and there's this pattern that's kind of showing up around these days. And I think I first saw it on Vesper, actually before iOS 7 came out. And I think I'm calling this like persistent views. So most of the time in a transition, if you have content that's the same on both your from view and your to view, especially in say a default navigation transition with a table view, and you're going to like a detail view, usually the detail view just slides in, and the content is kind of duplicated across those view controllers. But Vesper did something different where they kept the same content on the screen the entire time and just animated the new position, right? And I thought that was really nice because it kind of creates that consistency. Artsy's doing this pretty well, I think, as well. When you look at the relative size of a painting, right, they keep that view on screen. They transition to this other view, but it doesn't go away and just come in from the side. It stays there and just animates to its new position. All right, and so, an example, this is bad, right? Well, it's the same content. It's just on two different view controllers. It should stay on screen and just animate to the position, kind of like this. Right? That would be much nicer. And it's actually really easy to build. This is a little bit of code that would do it. So we have this shared view, right? Say we're back in our animated transition, and we have this shared view, and before we do the presenting, before we animate it, we just save off the starting center, the starting bounds, then we translate the center to the view it's going to using that convert point from view method, and then we add that shared view over to the new view controller, right? And then we animate it, pretty simple. But when you're dismissing, right, you're doing the reverse. So you're using that starting point and starting bounds that you saved off earlier to kind of animate it back, right? And then once the dismissal animation is finished, you add that, move that view back into its original view controller. And that's really about it. It's pretty simple. I mean, if you were doing multiple views, like Vesper, you'd probably have some kind of different object that would, control or like tell you which views would be involved and which of their starting points were and all that stuff. So this is kind of a simplified version, but it's the basic idea is just, all the shared views that you're going to do, you're going to store off the center and bounds, convert it to the presented views coordinate space, then add to the presented views hierarchy, animate it, and then on dismissal, convert it back to the presenting views view coordinate space and hierarchy. So I think using these principles can really bring some of our transitions to life. And there's some other ones that I haven't really had a chance to cover here, but they also could help do this, like anticipation, overlapping action, stretch and squash. And so these principles, there's a lot of content out there if you want to learn about them. They were originally written up in The Illusion of Life, which is a book by the Disney animators. It's written a long time ago, but still relevant today. You can check that out. And you can also read, John Lasseter wrote a paper along with Luxo Jr., where he applied the principles of these animations to Luxo Jr. to bring it to life, and how he did that and the challenges he faced. So, actually, hold on one second. Oh, whoops. You've created the perfect animated transition. Problem is, people have fingers, and they like to use them. And they use them in times where you wouldn't like them to use them, or they would like to use them. So in your transition, it starts coming in, and they want it to go away. Get out of here. They change their mind, right? But nothing happens. And that's because animated transitions are jerks and selfish. As soon as you start presenting a default or a custom animated transition, iOS says, let's stop getting interaction events until we're done, which sucks, right? And we're kind of entering this new age of always interactive. Why are we waiting for an animation to finish? So you can solve this problem by learning this one simple trick, right? Turn animated transitions into interactive transitions. Right? Interactive transitions are the second half of the new transition API in iOS 7. And of course, they don't ignore interaction events, because that wouldn't work. So all you have to do is take all of your code in animate transition and put it in start interactive transition, and you're done. And then you go home. Well, that's not everything, obviously. So start interactive transition. It's kind of like the interactive version of animate transition, right? You get that transition context parameter. And, if you think about it, interactive transitions usually go a little bit like, 5 minutes, all right. They usually go like this, right? You start with a gesture. Think of the pop, the default pop gesture on navigation controllers, right? You start with a gesture, and then you finish, when that gesture is done, you finish with an animation. So interactive animated transitions start with an animation, then maybe there's a gesture at some point, and if there is a gesture at some point, then it'll finish with an animation. So that would look something like this. All right, that works. And then that works. And then we can cancel it too if we didn't want to keep going, right? So obviously part of this is a gesture, right? So before we start that initial animation, we in this case, we're creating a pan gesture, but you could do like a pinch or whatever. And then we add this gesture to the container view. Another part you have to do is tell the animation that you want to allow user interaction. By default, that won't work. That'll block interaction. So we have to tell the animation system to do that. Oh, then, just animate it like normal. Allow user interaction. And then with the finally use that finish parameter. I was wondering what this was for, but they finally have a use for it. Because later, if a gesture does happen, we're going to cancel the animation. So if we cancel it, the completion handler still gets called, but with that finish parameter being false or no. And so we don't want to complete the transition if we cancel the animation. So just check that, make sure. Only if this animation is finished are we actually done with the transition. And we can remove the gesture and complete it. So if we do, say our pan gesture does begin, we have to cancel the animations. And since I'm low on time, I'm going to kind of go over this a bit. If you just search cancel iOS animation, you'll probably find out this common pattern of getting the presentation layer and then setting any property that you were animating to your view or layer, and then removing all the animations. And as your gesture changes, this is kind of stock, doesn't really have anything to do with transitions. You just translate the view along with it, right? But when it ends, we have to make a decision whether or not we should finish this transition or if we should cancel it. And so that decision is, maybe you could base it off the velocity of the gesture or the current location in the view. But once you make that decision, right, you have to let the context know whether this transition is finishing or canceling. Right? This is kind of just standard interactive transition stuff. And then after you do that, you animate to either off the screen or back, to the center. And then once that animation's finished, just complete the transition. So let's say that final animation, we were like, let's use ease in and ease out, right? That doesn't look great. It kind of looks like you're trying to throw something in mud or something. Yeah, that's not good. So I liked how the paper Tech Talks talked about this. Animation as physically degrading continuations of gestures. All right, there's like something supposed to happen there. So animations don't have a starting velocity input, right? We've got that velocity from the gesture. Why aren't we continuing the velocity with the animation? Well, Spring Animation does have an initial velocity parameter, actually. It's called initial spring velocity. And that's the docs. It says, for a smooth start to your animation, just match it to your gesture. So you pass in the velocity from your gesture and you're done. No, that doesn't work. So that initial spring velocity is really the velocity of your gesture divided by the distance that the animation is gonna be, right? So wherever you're finishing that gesture, some location, then you've got the animation where it's gonna finish. You have to figure out the distance and then use that as a divisor of your velocity. So if you pass that in, and you're using spring animation, obviously, it looks pretty good. It's like passable. There are other options. You could use dynamics or Facebook's pop, which is like pretty much designed for this thing exactly. You could do it manually. I suggest reading how do you say it? Objective-C-IO? I don't know. Objective-C-IO issue 12, interactive animations covers this really, really well. Please read that. So just remember to do this, to get these interactive animated transitions, move your code to start interactive transition, allow user interaction, remove those animations if the gesture begins, finish or cancel when the gesture ends, and then animate to the final position and complete the transition. One more quick thing. So if you're doing a navigation transition, you're going to end up with something like this, where the navigation bar is like a little slow. That's not good. And that's because we're not updating the interactive transitions percentage complete. We completely forgot about that. So if you're starting with the animation, and you're just maybe no gesture ever happens, you know, how do you update this percent complete? You're going to call this thing, you know, and throughout the whole animation. So the best way to do that is use a CA display link, which it's kind of like an NS timer, but it'll fire like on the refresh rate of the screen, so like 60 frames per second. So before your animation starts, that initial animation, you want to save off the current media time. We're going to use that later. Create that display link, and then add it to the run loop, which gets it started. And then so our animation's running, and then this is getting called 60 times a second, hopefully. And so we just update the interactive transition with our computed percentage completed, somewhere between 0 and 1, right? And then when we do that, make sure you invalidate the display link if the animation ends, right? Or just keep going. That's not good. So when you do this, then the navigation bar has a nice animation along with your own animation. So to build better transitions, take two things away, I guess, from this talk. Use the principles of animation to create that, to kind of mimic the physical reality, you know, create that physical context for your app. And then also, please, 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 do always interactive animated transitions. So thanks, that's it. That's it.